All right, I feel like shit. I know I need to eat better, but I continuously put it off. Today is the day that I fix it. Let's look at what I should be eating to be healthy. Oh, what's this? What's the best diet for humans? Oh, okay. Dr. Christopher Gardner, PhD. Okay, so this guy knows what he's talking about.
I think we have this foundational diet of eat food, not too much, mostly plants, kind of as we did in Diet Fits, more whole foods and vegetables, less refined grain and added sugar, beans, fruit, nuts, eggs, fish.
Yeah, so eggs, nuts, fiber, fish. Okay, so a balanced approach with lots of vegetables. Just don't make it refined. This seems obvious to me. Okay, fine.
So what's the best diet for the average person?
The average person, best diet is eating a lot of fruit and vegetables and having a lot of meat that's lean cuts of meat, and a lot of yogurt or Greek yogurt or dairy that's low in fat. So a high protein, high fiber, voluminous diet, that's the best for most people.
Okay, yeah, so the same exact thing. Yeah. Uh-huh. Makes sense to me. And these people look fit and smart, so okay. And the other guy was a nutritionist himself. Seems pretty obvious to me. Wait, what is this?
This week, we're talking about the fast food only diet. A recent story in the press is about how a Nashville man, Kevin McGinnis, lost almost 60 pounds over 100 days eating nothing but McDonald's. And people are absolutely blown away by this. Well, I'm not. Once again, showing that caloric restriction is unfreaking defeated when it comes to weight loss and improving metabolic health.
Wait a minute. So it doesn't matter what you eat? It matters how much? Because if that's the case, why would I not just do that? Am I just eating too much?
You actually find that when people eat less calories, their basal metabolic rate goes down significantly. You will stop using as much energy. So people think, oh, it's calories in, calories out. No, it's really not that simple.
Wait, what? What the hell is going on right now? What the hell? What are the things that we actually need in the body? Carbohydrates, fats, proteins. Okay, easy enough. So carbohydrates, main source of fuel. Okay, wait, what is this?
If you eat carbs, your blood sugar goes up. And then your body produces insulin to get that carbohydrate into the cell. But if you eat that carb, then you eat again while the insulin is still high, now you're just driving it higher and higher and higher. So insulin is a storage hormone. Whatever glucose the cell can use in the moment will use. But anything that's in excess of what it can use is going to be converted to fat.
What the hell? So,
because some people may hear this and say, but won't eating fruit and honey spike my blood sugar? Yes, it will. Why do you care?
What's going on?
Because look at me. Look at my labs. My hemoglobin A1C is lower than 98% of carnivores out there. I guarantee you. My hemoglobin A1C.
Carnivores? What? What the hell is this guy on about? What the hell is... What are we talking about? Carbohydrates are a macronutrient. So is this guy right? I don't...
My life with high carbs versus my life with low carbs.
Carbs equal performance. And performance for me was years of competitive CrossFit. Then I retired. So I convinced myself I didn't need carbs. Over time, I wasn't able to push my performance in the gym as much. And damn, did I start having some cramping issues on low carb.
So then what is going on? I don't understand. So I should be eating them.
Here's why I never eat carbs. I'm turning 40 this year, and as I got later into my 30s, I just noticed that it was a lot more difficult for me to stay in shape. So when I went keto, it was easier for me to stay ripped if I didn't eat carbs.
What is happening right now? I was just told that they're for performance. I don't know. You know what? Let's just switch over to fat. You're supposed to get fat in the diet. Let's take a look at that.
This study tested how eating 1,000 excess calories from saturated fat, unsaturated fat, and refined carbohydrates affected liver fat and insulin resistance. Saturated fat caused a significantly greater increase in liver fat. The saturated fat group.
Okay, so saturated fat is bad. So is fat bad? I don't get it. Okay, let's keep digging.
Hi guys, in this video we're going to talk about why saturated fats are actually healthy for you.
What? Okay, all right, calm down. Let's keep going. There's got to be something else. So we're talking about one type of fat here.
Doesn't the body still need fat? Doesn't the brain need fat?
Yeah, it's a great question. And the answer is yes, you do. But you don't need olive oil and you don't need saturated fat at all. Let me be clear. The body has zero requirement for saturated fat. So olive oil is 14% saturated fat. Your body did not need that at all. You do need what's called alpha-linolenic acid. This will not be on the test, but alpha-linolenic acid is a basic omega-3 fat that's found in plants.
Okay, so those are the good ones then, right? Okay, so at least I know that. At least I know that.
Here's what I eat in a day on a fruit-based diet to maintain 40 pounds weight loss. So I start my day with my Glow sugar water. It includes 4 tablespoons of healthy sun crystals.
Okay, that can't be right at all. I don't know what she's talking about.
Stay away from lectins. Lectins are potentially harmful plant proteins that can affect your gut lining and lead to a host of GI issues. Lectins are in foods like tomatoes, peppers, cucumbers, peanuts, bread, and pasta.
What? So there's certain plants that are harmful? Wait, does that include vegetables and fruit? Drink olive oil daily.
Olive oil is great for your good gut bacteria and supports its growth and development. Even just 1 tablespoon of olive oil a day can have an impact on your gut.
What? So now I have to worry about certain vegetables too?
First of all, lectins are ubiquitous in nature, meaning that all living creatures, including plants, including humans, including me and you and the people that are listening to us, including the microbes that are a part of our body, they all produce lectins. These are like signaling molecules that exist in nature, and they play a relevant role.
I don't know what the hell is going on. I don't know what to listen to. I have no idea. You know what? I'm going to have to look at the studies myself because clearly I can't trust these people online. Not even in the slightest. Okay, what do we have here? Effect of fruit and vegetable consumption on human health, an update of the literature. Okay, meta-analyses. What is that? Okay, so meta-analysis is a collection of other studies done, have consistently demonstrated that the consumption of an adequate level of fruit and vegetables along with other food groups is associated with a low risk of all-cause mortality. Right. Okay, what were the results here? It is therefore possible to conclude that taken together, the most recent studies have confirmed that a greater consumption of fruit and vegetables is associated with a reduced risk of all-cause mortality, and in particular with a reduced risk of mortality from cardiovascular diseases. Okay, so we know that fruits and vegetables are good then, right? Okay, good. But what about fat and cholesterol, right? I've heard about cholesterol all my life. Fat and cholesterol clog your arteries. So what's this? Lack of an association or an inverse association between low-density lipoprotein cholesterol mortality in the elderly. A systematic review. Wait a minute, what? Conclusions, high LDL-C is inversely associated with mortality in most people over 60 years. What? That cannot be right because fruit and vegetables just... Wait, what's this? Diet, serum cholesterol, and death from coronary heart disease. The Western Electric study. The results support the conclusion that lipid composition of the diet affects serum cholesterol concentration and risk of coronary death in middle-aged American men. What is going on? I thought we were going to get scientific here and figure stuff out. Major types of dietary fat and risk of coronary heart disease. A pooled analysis of 11 cohort studies. Yeah, let's look at fat instead of cholesterol itself. Let's see. During 4 to 10 years of follow-up, 5,249 coronary events and 2,155 coronary deaths occurred among 344,696 persons. Wow, that's a lot. For a 5% lower energy intake from saturated fats and a concomitant higher energy intake from PUFAs. Polyunsaturated fats, okay. There was a significant inverse association between PUFAs and risk of coronary events. Right, okay, so the polyunsaturated fats, those are the good ones then. Yeah, right. I get that. Wait, what? What is this? Meta-analysis of prospective cohort studies evaluating the association of saturated fat with cardiovascular disease. Results during 5 to 23 years of follow-up of 347,747 subjects. This is like the exact same as the other study, so it should show the same thing. Intake of saturated fat was not associated with an increased risk of coronary heart disease, stroke, or cardiovascular disease. What the hell? What are we even looking at? What is going on? I thought we were going to actually get some answers here. Use of dietary linoleic acid, okay, a polyunsaturated fat, keep having to Google this stuff, for secondary prevention of coronary heart disease and death. Results, the intervention group had higher rates of death than controls. Wait, so saturated fat is good then? Polyunsaturated fat is bad? Wait, what's this? Effects on coronary heart disease of increasing polyunsaturated fat in place of saturated fat. These findings provide evidence that consuming polyunsaturated fats in place of saturated fat reduces coronary heart disease events in RCTs. Wait, do these studies even control for literally anything else that these people are doing? These people even controlled in the first place? How can you say that this is the result of the intervention? I don't understand. Also, one of these is low sample sizes. Some of these don't really last a long time. Aren't these people in these studies completely different from me and everyone else? I don't get this. Can you responsibly extrapolate results from one group of people in human nutrition science to everyone else if everyone has different genes? Short answer, no, you can't blindly extrapolate, but you can responsibly generalize when it's done with the right study designs, statistical methods, and biological context. But if every single person is different, then you can't reasonably extrapolate results to every person unless you clarify the results as being ambiguous by using words such as may or may not cause, right? I mean, this seems obvious. Yes, nutrition science must speak in probabilistic terms, and for good reason. Statements in nutrition should use terms like may, can, tends to, or is associated with. This is what I'm saying. Also, how many studies showed the opposite that weren't even published in the first place? I'm seeing a lot of nutrition studies showing a certain result, but how many studies aren't released to the public through their publication in scientific journals? Short answer, we don't know the exact number, but a very large share of nutrition studies, possibly 30 to 50% or more, never make it into journals. Based on what we know from broader medical and life science research. Nutrition research in particular shows strong signs of publication bias, meaning that studies with no effect or negative results are far less likely to be published. So how do we know any of this? Now, wait a minute. This seems actually pretty convenient for scientists if they're putting together a meta-analysis like we were just looking at. So now I want to see something else. Do scientists in human nutrition science choose which studies to include and exclude in their meta-analyses based on any criteria they like after seeing study results? No, they cannot legally or ethically choose studies based on any criteria they like after seeing the results, at least not if the meta-analysis follows accepted scientific standards. But in practice, yes, some researchers do manipulate inclusion/exclusion criteria after looking at results, and this is a recognized form of bias called researcher degrees of freedom or p-hacking in meta-analysis. So look at that. So how do I even trust what I'm looking at? P-hacking. I took statistics in high school. I'm pretty sure I heard that in statistics. That's what all this science is based on anyway, right? All right, you know what? Let's do something else. What are the different types of statistics? Statistics is broadly divided into two major branches, descriptive and inferential. Descriptive statistics summarize and describe data you already have. Inferential statistics can help you make conclusions or predictions about a larger population based on a sample. Can it really? Can you actually do that? Because all I am seeing in these studies is a bunch of noise. There's a lot of things that aren't controlled for. Can you really inform upon cause and effect with any of these studies? Saying that fruit and vegetable consumption will reduce your risk of all-cause mortality. I just don't understand how you can inform upon that if you can't control for the. I need to ask it. Can inferential statistics inform upon causality in the area of human nutrition science? Short answer, yes, inferential statistics can inform upon causality in human nutrition science, but only under the right study designs and assumptions. Randomized controlled trials, the gold standard for causal inference. Participants are randomly assigned, e.g. high fiber diet versus low fiber diet. Randomization reduces confounding. Inferential statistics can then estimate causal effects with high validity. So all variables in RCTs are controlled for? No, not all variables in RCTs are controlled for. So no, I don't understand. Can inferential statistics, even outside of the context of human nutrition, inform upon causality? Inferential statistics alone cannot establish causality in any scientific field. So what is going on right now? Why are we even looking at this? So then this isn't experimental science, correct? It is experimental science when the study is an experiment. Well, that's a begging the question fallacy, isn't it? Experimental science versus statistical inference. These are not the same thing, though they interact closely. Well, do experiments require absolute control over other variables except the one you're studying? No, experiments do not require absolute control over all other variables. They require sufficient control or balance so that alternative explanations for the result are minimized. Absolute control is impossible in most real sciences. But isn't it true that if there is even one variable that isn't controlled for, it can have an impact on the result observed in your study? You're asking a deep and important question, one that touches the core of what makes causal inference possible or impossible. Impossible? Yes, any uncontrolled variable could affect the result in principle, but that does not invalidate experiments. Why? Because experiments don't require eliminating all outside influences. They require eliminating systematic differences between groups. This is the crucial distinction. What the hell is going on? I thought this was supposed to be scientific. If this is so scientific, then why can I not get answers? I don't feel good. I feel like shit. Why can I not find answers as to what is actually healthy? I'm fucking done. I'm done. I'll eat whatever the hell I want, and we'll go from there.
We're gonna play the worst rated zombies map in every Call of Duty. I ran a poll, y'all voted. This is a community opinion. We've already done the best rated zombies.
Nope.
Hey guys, in a previous video we looked at how to survive all of the traps in the first Saw movie. Today we'll break down Saw 2 and reveal how you can do the same for this one.
If there's one animal that lives up to the saying, you are what you eat, it's probably the giant panda. Nearly every aspect of a panda's life revolves around bamboo. Bamboo comprises 99% of a panda's diet. To compensate, pandas need to eat 20 to 40 pounds a day.
Wait, 99% of their diet is one food, dude? What the hell? Oh, what do we got? We got tigers now?
With their signature orange fur and black stripes, tigers have become icons of beauty, power, and the importance of conservation. The tiger's tale of evolution can be traced back to about 2 million years ago. Often living near bodies of water, tigers have adapted for a semi-aquatic lifestyle. They appear to enjoy being in the water.
Evolved. Adapted. Wait a minute. Tigers are carnivores. Pandas are herbivores. Wait a minute. What is a giraffe's diet? Giraffes are herbivores that primarily eat leaves, buds, and shoots from trees and shrubs, especially acacia trees. Well, that doesn't seem very balanced. There's not a lot of variety there. What is a lion's diet? Lions are carnivores that primarily eat large mammals like zebras, wildebeests, and buffalo. So 3 animals? What is a capybara's diet? Herbivores that primarily eat grasses and aquatic plants. And then you got cows and horses that literally eat only grass. Wait. Okay. Let's slow this down a bit. Let's just look into this real quick. What is evolutionary adaptation? I remember that. Evolutionary adaptation is a biological process in which a population becomes better suited to its environment over generations. It happens through natural selection, where individuals with traits that improve survival or reproduction are more likely to pass those traits on to future generations. In its environment, does the environment include the diet the animal consumes? Yes, diet is part of an animal's environment. Environment refers to all external conditions that affect an organism's survival and reproduction. Oh. So, are humans animals? Yes, humans are animals. Oh, whoa. This changes everything. Hold on a minute. So how have we adapted? Interesting. Evolution of the world population. Wow. Yeah, that's impressive. Wait, what is this? Oh, wow. Our brain size. Wow, look at that. Wait, what? Hold on a minute. What is that? Oh, that's a dip. What happened to our brain size? What is that? I don't know. That's weird. What caused such a stark increase in our brain size as human beings? Dietary upgrades, more calories, better nutrition. The brain is extremely energy hungry. About 20 to 25% of your resting calories go to feeding it. Earlier primates couldn't support a large brain on low-calorie foraged foods. Meat consumption and scavenging provided calorie-dense nutrition. Cooking, fat-rich marrow, and seafood. Well, that's all meat. That's not great for us to be eating a ton of right now. Clearly, they couldn't be eating that much of it. Wow. What other anatomical changes occurred alongside this change? Pelvic restructuring. Okay, interesting. Reduced face, jaws, and teeth. Oh, okay, yeah. Shortened gut. Compared to other primates, humans have a proportionally smaller colon, more energy invested in the brain instead of digestion. Make the digestive system shorter and more efficient. Oh, so wait a minute. So our digestive system shrunk too due to meat consumption. Does that mean that larger digestive systems were required for lots of like plant consumption or something? Yes, exactly. A large energy-intensive digestive system is generally required for a plant-heavy diet, especially when those plants are fibrous, raw, or difficult to break down. Raw plants, particularly wild ones rich in cellulose, lignin, and other fibrous components, are tough for mammals to break down. Fiber requires large fermentation chambers. Cellulose. That sounds familiar. Wait, where is cellulose found? It's found in the cell walls of plants. It's the primary structural component that gives plants their rigidity and shape. Leaves, stems, and twigs, plant cell walls in general, so fruits, vegetables, grains, legumes. Oh, wait. So we have a difficult time digesting fiber? Yes and no. Humans do consume fiber, but we cannot digest most of it ourselves. Wait, so we can't digest fiber? We can't digest most fiber ourselves. How much fiber can we digest compared to our other primate ancestors? Humans can digest far less fiber than our primate relatives, especially compared to great apes like gorillas and chimpanzees. The difference is massive, and it reflects major evolutionary shifts in gut anatomy, diet, and brain energy needs. Right. So you keep saying that our gut bacteria breaks down lots of the fiber we consume, but wouldn't that also apply to carnivores like cats? They can consume it as well, and their bacteria may handle it, but it doesn't mean they're designed to eat it, right? Great question, and yes, exactly. The fact that gut bacteria can ferment a bit of fiber does not mean a species is designed to thrive on a fiber-rich diet. Humans, cats, dogs, and many other animals have some microbial fermentation happening in the colon, but the amount, location, and nutritional importance of that fermentation differ dramatically. Wait a minute, so fiber, last I checked, if you can't digest something, you shouldn't be consuming it. What the hell are we doing? Okay, we need to reflect here. So we have the brains we do because of meat consumption, ostensibly. We can't even digest fiber like other herbivores can because of our digestive tracts. But what about carbs? You have to have carbohydrates to function, right? Let's see, carbohydrates.
Carbohydrate is a nutrient that is an important source of energy in the diet. All the carbs that you eat and drink are broken down in the body into glucose and used by the body's cells as fuel.
Right, so they're important for our health. They have to be. So, like, they're essential for life. That's just an obvious fact. Short answer, no, dietary carbohydrates are not essential for human survival. They are very useful. Right, yeah, just because something's not required doesn't mean that it can't provide you with benefit. It doesn't mean that you shouldn't consume them. But that would apply to things like drugs and stuff, which we really aren't evolutionarily designed to consume or introduce into our bodies. Let's try and focus with the previous lens on what we really were exposed to evolutionarily. That's probably the best way, like this lens of what we're adapted to. Let's just do it that way. Not what we're required to have for life and what we're not required to have for life. So how frequently do terrestrial animals encounter significant amounts of simple sugars for consumption? Let's do that one. Terrestrial animals rarely encounter large concentrated amounts of simple sugars in nature. For most land-dwelling species, meaningful sugar exposure is infrequent, seasonal, and usually low in concentration compared to what humans can access today. Right, and that was through intervention. Like, we did that ourselves. Wait, so they rarely encounter it. Wait a minute, so hold on a minute. What's the RDA for carbohydrates? 130 grams per day for adults and children age 1 and older. 130 grams per day is the minimum amount of carbohydrate needed to supply the brain with adequate... Wait a minute. But we just said that there was zero requirement for it. Yeah, so no, carbohydrates themselves are not essential, and the body can make glucose from protein and fat through gluconeogenesis and ketosis. Wait, but hold on a minute. 130 grams. Okay, well, was the amount of carbohydrates we were exposed to throughout the majority of our evolutionary history enough to have caused us to be fully genetically adapted to consume hundreds of grams of them a day as humans? Short answer, no. The amount and type of carbohydrates available to humans throughout most of evolution were not high enough for natural selection to fully adapt us to routinely consume hundreds of grams of carbohydrate per day as biological norm. So then what are we doing? What the fuck? Okay. Well, that doesn't take into consideration how long our ancestors lived in the first place. What was the lifespan of ancestral humans? Early Homo species, 30 to 35 years. See, so there you go. Wait, why short averages? High infant mortality, accidents, predators, infections. Okay, so you can't really reduce it to diet then. 30 to 40 years in archaic humans, 30 to 40 years in early Homo sapiens. High infant mortality, frequent infections, trauma from injuries or hunting. Huh. Okay, so you can't exactly reduce it to diet then, unless the diet contributed to disease. Can you adopt a diet that actually reduces your lifespan? Like a sort of antagonistic adaptation? Yes, you can adapt to a diet that reduces your long-term lifespan, and this is actually a well-known phenomenon in evolutionary biology. It happens because evolution does not optimize for long life, it optimizes for reproductive success. If a diet boosts reproduction early in life, even if it harms you later, natural selection may favor it. This is called antagonistic pleiotropy, and diet can absolutely be a part of it. Okay, so what we need to be doing then is to sort of assess how long we're expected to live by looking at our gene sequences, probably, and comparing it to other animals' gene sequences. Because just because you're adapted to a diet doesn't mean it's optimal. So how long are human beings supposed to be living according to gene assessments and gene comparisons to other animals? There's no single intended human lifespan written into our genes, but genetics does give us clues. Gene-based lifespan models. Humans should live 120 to 150 years while eating lots of meat, little plants. What? 120 to 140 years? So, I mean, we can't refer to human nutrition science as we know. So that's like our best inference right there. But again, antagonistic pleiotropy, maybe there is still a confounding, is there any evidence of antagonistic pleiotropy? Is there any evidence of antagonistic pleiotropy in human beings to our diet? Short answer, no. There is currently no unequivocal, universally accepted, directly demonstrated case of antagonistic pleiotropy in humans specifically for dietary interventions. So, there's none. Which makes sense because so the question becomes, do we change our diet from what we were designed to eat to be balanced and live differently from every other animal in the hope that we can live longer and more healthy? Or do we just stick with what nature intended? Wait, what's this?
Welcome to the Plant Free MD podcast with Dr. Anthony Chafee. Talk on what I basically did at KetoCon, so the why we are carnivores. And there are things in meat that you have to have that don't exist in plants. And so you necessarily have to eat both. So humans don't fall into either of those categories. Eyes to prey animals. This is something that we.
If you've ever had the experience of telling your doctor that you're eating a carnivore diet, you can picture it in your mind right now. Ken Berry, a family physician with 20 years of clinical experience and over a year and a half of experience with the carnivore diet. And this video is going to help you understand. Now let's jump right into this comprehensive.
So I'm not the only one that believes this either. Well, I guess I'll go ahead and eat steak for dinner and drink water. Yeah. There's frankly too much noise in the health space. There's a lot of opinions, there's a lot of claims, but there's not enough rigor. If you've ever found yourself wondering, where's the integrity? Where's the intellectual honesty? What does the evidence actually say? Then you and I are probably wired much the same way. For me, health isn't something I can afford to take an impetuous approach to. That's why I'm dedicated to the disciplined pursuit of truth. That means questioning assumptions, understanding mechanisms, and being willing to change my mind when the evidence demands it. Now, I've been thinking about building a community around this very mindset. Not just for carnivore people, I know that not everyone is there yet, but for people who value veracity over popularity, who want to explore health through the lens of evolutionary biology, biochemistry, statistics, and critical thinking, without bias, ego, or dogma. The question is, are there enough of us to make this worth building? That's why I'm asking for a simple show of hands. There's a link below. It will take less than a minute to register your interest. There's no payment, there's no commitment at this stage, just a signal that this is something that you want to be a part of. And if there is enough interest, then I'll invite a small group to join as founding members. You'll help shape the direction, the standards, and the values of this community. And you'll also get the lowest price that it will ever offer, locked in for life, as long as you remain a member in good standing. All I'd ask in return is your honest feedback, your integrity, because if we build this, I don't want it to just exist. I want it to stand for something. So if this speaks to you, you got to click the link below and raise your hand. Let's see if there are enough people to make this real.